we know that metals vary in reactivity. For example, group 1 metals, the alkali metals, are the most reactive since they have only one electron, and this electron is easily to be lost. And as we go down the group, we have more reactive metal. As the valence electron, the last one, which is easier to be lost, becomes actually further and further from the nucleus, so the attraction force between the nucleus and this valence electron becomes less until it is easily to be lost. So we have magnesium in group 2, calcium in group 2, iron is a transition metals, zinc and copper. These the metals that we have right now. If we had metals from group 1, such as potassium, sodium, lithium, they would be more reactive than these metals. So, if we have these metals right now, by looking at the number of the bubbles here, we can determine which metal is the most reactive. Between magnesium, calcium, iron, which one do you think is the most reactive here? Calcium is the most, since it has the most number of bubbles. As we have more bubbles, that means we have a stronger reaction, we have more vigorous reaction, and so on. This reaction between metals and dilute hydrochloric acid, it's very important to know that acids that are used in the labs are dilute, not concentrated, because concentrated acids are corrosive. They eat your skin away. That's why they are not used in the labs. Now, according also to reactivity series that I sent it to you, reactivity series, we can use it to predict if any reaction can happen or cannot. If the reaction happens is vigorous or is not. If the reaction happens with water or if it doesn't. If it happens only with acid, if it happens with oxygen, and so on. Now, here we have zinc and copper test tubes are empty. And you are asked to draw the number of bubbles, the expected number of bubbles here. According to reactivity series, zinc is less reactive than magnesium, but it is more reactive than iron. So we count the number of iron here, the number of bubbles in the iron, and we count the number of bubbles in magnesium. And we take any number between iron and magnesium, we draw it in the zinc test tube here. About copper, copper doesn't react with dilute acids at all. So we should not draw any bubble here. Okay? Okay, according to reactivity and according to reactivity series, I want to illustrate displacement reaction. Displacement, when any metal displaces another metal or kicks any other metal from its solution. The most reactive one kicks the least reactive one. If we have iron here and we have copper sulfate solution, copper sulfate is a salt. Copper sulfate, this salt we added to water to make solution here. So this solution contains copper, but copper now is not a metal anymore. Is not shown as pieces of copper, reddish or brownish pieces. Okay? It is now a compound. It has different properties than copper. So copper sulfate is a compound that contains copper and sulfate ions combined together to make copper sulfate. Now, iron, as we know according to the reactivity series, is more reactive than copper. So once we add iron nail, we place it in this solution and we leave it for a few minutes, or we can leave it overnight to see more illustrated results or clearer results. We can leave it overnight. So here, iron nail is placed in copper solution. After a while, iron displaces copper from its solution. Okay? Iron displaces copper from its solution. So the copper pieces will be shown as reddish or brown pieces. They're gonna wrap the iron nail here. So before this, copper sulfate was blue. Okay, it's a blue copper sulfate. But after this, the iron gonna get trapped by copper pieces which are reddish or brownish. Okay, and once we have blue gets mixed with the pieces of copper which are reddish yellowish, then will we have a green copper sulfate. That's why it becomes from blue to green, as copper pieces here are shown after the reaction, after displacement has happened, after iron has displaced copper and kicked copper out from its solution. So copper now is shown and iron takes the place of copper, and the reaction would be as the following: iron sulfate, because iron now combined to sulfate instead of copper, and copper here is shown in the middle. Now it's been kicked out. So according to reactivity series, we can predict if any reaction happens or if it doesn't. The most reactive one kicks the least, of course, and the more kicks the less. Thank you.